After the closure property of whole numbers, now it's turn for commutative property of whole numbers. And let's start with addition first. So for addition first, commutative property. In case of addition, what commutative property means is, suppose you have two numbers A and B. Okay, so if A plus B, so can you write it as B plus A? Would these two be equal? That is what actually the commutative property is. And you can check it by example, like if you take A as 2 and you take B as 3, and if you add it, you'd get 8. And if you take B first, that is 3, and that is plus 2, and even in this case you'll get 8. So this A plus B is equal to B plus A. That is, the operator is same, that is, the operator is addition sign here is same, but you have reversed the order. You have reversed the order of the numbers, and therefore at the place of A you got B, and at the place of A you got B, and at the place of B you got A. Therefore, addition of whole numbers follow commutative property. They follow commutative property, that is, they follow commutativity. That is, if you change their order, then they will give the same answer. So this was for addition. Now let's do for multiplication. Let's do for multiplication. Now, what does that mean is, A multiplied by B, is it equal to B multiplied by A? If yes, then it will also follow the commutative property of whole numbers. The multiplication of whole numbers will follow the commutative property. And therefore, to check this, you can take the same example of 2 and 3. So 2 multiplied by 3 would give you 6. And 3 multiplied by 2 would give you 6. In both the cases, you got the same answer. Okay, what you did, at the place of B, A, you put B, and at the place of B, you put A, and therefore you got these two different expressions, but you got a same answer. Therefore, even multiplication, just like addition, follows commutativity. It follows commutativity, that it follows the commutative property. Now let's do for subtraction. Okay, so before going to subtraction and division, now you would be thinking that, hey, what's the use of this? So let me take you an example for multiplication case. Suppose this is a room. Okay, this is a room, and in this room, you have to make arrangement for 32 members, for 32 persons, for 32 people. Okay, for 32 people, and you say that, okay, what we can do is let's make 4 rows. Let's make 4 rows. 1 row, 2 row, 3 row, and a 4 row. And in each row, let's put 8 chairs. So chair number 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So in each row you put 8 chairs. Therefore, there were 4 rows, and in each row there are 8 chairs. Therefore, in 4 rows you will have 4 multiplied by 8 is equal to 32 chairs. Okay, so total would be 32 chairs for 32 people, but in 1 row there were 8 chairs. What if the organizer tells you that, hey, we can only put 4 chairs in a row, because that is what the capacity is. That is what the capacity of the hall is. We cannot put more than 4 chairs. Then what would you do? You have to make arrangement for 32 people, and for arrangement of 32 people, there is a condition that in one row you can only put 4 chairs, not more than that, because that is the capacity of the hall. Okay, so what would you do? So you would say that, okay, what we can do is, we don't have any restriction, we don't have any constant on the number of rows, we have only constant on the number of chairs within a row, and that is 4. So what we can do is that, if one row contains 4 chairs, what we can do is, let's make 8 rows, and in each row there will be 4 chairs, and therefore we'll get total 32 chairs, and therefore these 32 people can sit on that. And if you would notice that this is what same thing, that 4 multiplied by 8 is equal to 8 multiplied by 4. This is a real life example, and you can relate this, that how is the multiplication that follows the commutative property is useful in our day-to-day life. And this was example. In both the cases, you see that you are getting 32 as the answer, and you can see that multiplication is following the commutative property. So this is one of the real life example. Now let's move towards the subtraction. For subtraction, so if subtraction follows the commutative property, what does that mean? What does that mean is, if A minus B would be equal to B minus A, right? If you change their order, if you change the position of A and B, so in order to follow the commutative property, the answer should come equal. And you can take the example. So if this is A was 2 in this case and 3 here, so 2 minus 3, and in this case it would be 3 minus 2. Are these two same? No, they are not same. They are not same. This is minus 1. This would come minus 1, and this would be 1. So of course minus 1 is not equal to 1, right? This is not a whole number. And you are not getting, you're not getting the same number, desired result. Therefore subtraction does not follow. It does not follow the commutative property of whole numbers, and therefore it does not follow the commutativity. And last one is for division. Last one is for division, and for division to follow the commutativity, it means that it will have to be that A divided by B will have to be equal to B divided by A. And you can check it with any example, like suppose you are taking it say 4 divided by 2. So is 4 divided by 2 same as 2 divided by 4? No, of course not. Here you will get the answer will be 2, and here the answer would be 2 by 4, or you can say that 1 by 2. Okay, so the answer is coming 1 by 2 in this case, and in this case you have 2. Of course these two are not same, and therefore for division of whole numbers you will not always get this, you will not get the same result if you change their order or change their position. Therefore, just like subtraction, division also does not follow the commutativity. Only addition and only multiplication of whole numbers will follow this commutative property. And here we can relate a real life example. Just we saw here that how is this commutative property of whole numbers is important for us. And in next video we'll learn about the associative property of whole numbers. So after learning commutative property, now it's number of associative property, and let's jump straight with the addition of whole numbers. And for addition of whole numbers to follow associative property, that would mean that is it possible that A plus B, and these are grouped together, and plus C, is it equal to A plus B plus C grouped together? Is it equal to A plus C plus B grouped together? You can see that first grouped A and B together, then B and C together, and then A and C together. Is it possible for them? So let's check with an example. Take A as 2, B as 3, and C as what? 2, 3, and 4. So what would be the answer? The answer would be 5 plus 4. It would be 9. Now let's do for this one. So 2 plus 3 plus 4, and it would be 2 plus 7 is equal to 9. So here also in the previous one you got 9, here also you're getting 9. Now let's do for this one. So this would be 2 plus 4 grouped together plus 3, and this would be 6 plus 3, and this would give 9. So you could see that in all the cases you're getting the same answer, and therefore the addition is following the associative property. It's following the associative property. Okay, now let's do for multiplication. Let's do for multiplication. Now for multiplication of whole numbers, and to say that they follow the, if they will follow the associative property, then that means that A multiplied by B multiplied by C would be, and if A and B are grouped together, then should be equal to A multiplied by B multiplied by C. That is A times B multiplied by C, and would be equal to A multiplied by C B times. That is, first you group together A and B, then B and C, and then A and C. You just change the grouping. And is it possible that you are going to get the same answer each and every time when you are grouping the different numbers together? And to check that, take the same numbers, right? So take 2 multiplied by 3 and multiplied by 4. What would you get? You would get 6 multiplied by 4, and therefore the answer you would get is 24. Even in this case, this is 2 and then 3 multiplied by 4, and this would be 2 multiplied by 12, this would be 24. And even in this case, it would be 2 multiplied by 4 multiplied by 3, and it would be 8 multiplied by 3, this would be 24. So you could see that in all the cases you are getting the same answer, and therefore just like addition, the multiplication of whole numbers will follow the associative property, just like addition. Now you would be thinking that, hey, how to apply that? Where would we apply in real life? So for both these two cases, that is for addition and multiplication, to follow the commutative property and the associative property, what they do is they simplify the arithmetic operations. That they simplify the steps taken. So you would say that, how could we see that? So let me explain you with an example. Suppose you are given an example would be 12 multiplied by 35. Okay, 12 multiplied by 35. Now if you're asked to find the answer of this, what you can do is first you will do 2 multiplied by 6. Suppose you write 2 multiplied by 6, because this will be 12 only, and this is 35, right? And this is 35. Now what you would do is you will interchange a position, right? What you're performing is the commutative property. You are performing the commutative property. Okay, so you interchange a position. Here you perform the commutative property, therefore it would become 6 multiplied by 2, right? 6 multiplied by 2 and multiplied by 35. Now here, first 6 and 2 are grouped together. Now what you would do is you would group together 2 and 35. Okay, you are performing this associative property. First, when you interchange the order, the position, right? So here you're actually you're using the commutative property of multiplication, right? You use the commutative property of multiplication, and now what you're doing is you're grouping two different numbers. Previously it was 6 and 2 grouped together. Now in this case you're grouping together 2 and 35, and therefore what you would get is 6 multiplied by 70, and therefore it would be 420. Okay, this would be 420. So how this helped? I mean, it would have been tough for you to multiply 12 and 35. Okay, but in this case you could see that just by interchanging their position and then grouping two different numbers, what it gave you is this 70, and now you can easily multiply and get 420. As you'll go in the higher classes and as you'll go in your either in the college courses or in the intermediates or high school, then you would see the importance of these, just interchanging the position, grouping different numbers together, so that you can get your answer as quickly as possible, and it will save your time. Now let's move for subtraction and division. And why don't you just similarly check for the subtraction whether that will follow or not, whether it will follow or not. Like if you are given say 3 minus 2 grouped together and then minus 1. Okay, so is it possible that you can write it 3 minus 2 minus 1? Will it be equal to it? Will it be equal to it? So you can check that this will be 1 minus 1 would be equal to 0, but this would be 3 and minus 1, 3 minus 1, and it would be 2. So these two numbers are of course not equal. Okay, so like addition and multiplication were following the associative property, subtraction is not going to follow. It will not follow the associative property of whole numbers. And similarly for division, even for division, they will not follow the associative property. And you can check it like 2 divided by 3 divided by 4. Is it equal to, and 2 and 3 are grouped together? Or let me take some other example to make it easier. So suppose you have say 8 divided by 4 and divided by 2. 8 and 4 were previously 8 and 4 are grouped together. Now if you group together 4 and 2, are they going to be the same number? So if you divide 8 by 4, if you divide 8 by 4, first for this one, if you divide 8 by 4, you would get 2 divided by 2 and you would get answer 1. Now let's do for this one. So this is 8 divided by 2 and this would give you 4. So of course these two answers are not sim. These two answers are not matching, and therefore just like subtraction, division would not follow the associative property of whole numbers. So only addition and multiplication of whole numbers will follow the associative property, just like the commutative property, and subtraction and division would not follow the associative property, just like the commutative property. So the last property of whole numbers that we have to discuss is the distributivity of multiplication or addition. And for that it is if A times B plus C. If A times B plus C, if this will be equal to A times B plus A times C. Okay, that is, first Mr. A will attack it and then Mr. A will attack it. Okay, with this sign. So if A times B plus C is equal to A times B plus A times C, then that is the distributivity of multiplication or addition, and it holds true. And I'll explain you with an example. And the example is, suppose I take is 2 multiplied by 5, or let me do it like this. That is 2 multiplied by 12. And if I can write it like this, 2 multiplied by 6 plus 6. Okay, I've just expanded it, and therefore it would be 2 times 6 plus 2 times 6. In this case, the answer would have been 24, and here it would be 12 plus 12 is equal to 24. So you could clearly see that in both the cases, the answer is same, and therefore it follows the distributivity of multiplication or addition. This is distributivity of multiplication or addition, right? This is the case, and therefore it follows. In this question, you have to find a sum by suitable rearrangement. And what does that mean? What do you mean by suitable rearrangement? By suitable rearrangement, we mean that we have to use the properties of whole numbers, that is associative property or commutative property or distributive property of whole number. And using those properties, you have to make the rearrangement, and then you have to find this either the sum or the multiplication. And in this question you have been asked for addition, that is for sum, and therefore we'll see that how we use our properties and make the rearrangement. The basic point of doing the rearrangement is just to simplify our expression and to find the answer. Of course, you can go for, you can first add 837, then 208, and then 363, right? Like you can do like this. It's 837, and then you can do 208 and then 363, the very normal way of doing the addition, and then you can get the answer. But then what's the point of understanding, studying or learning the properties of whole numbers? Of course, they provide us an easy way to solve our problem, okay, and our arithmetic operation gets easier. And let's see how. So whenever you are asked this question, such questions where you have to make some rearrangements and then you have to find the solution of either multiplication or addition, then just keep one thing in your mind. For at your level in your class, that always make the arrangement so that you could get a zero number, a zero digit at the last of the number. Make the arrangements so that you can get a zero at the last of the number. Like here you could easily see, if I attack, I'm using some layman words, but it's just to explain you and for the fun, that if 7 gets attracted towards 3, of course 7 plus 3 would make 10, right? And you could clearly see that if we group together these two numbers, 837 and 363, then of course we are going to get a number which will be surely having a zero as a digit in the last, zero as a last digit, okay? And that would simplify our problem, that would simplify our steps for the further addition. So what you have to do is you have to just make the rearrangement like this, that is 837 and then 363 and then 208. Now notice that I have changed the order. And what property you have used here? Of course, you have used here commutative property of whole numbers. And if you remember that we had discussed there that the commutative property of whole numbers means that if if A plus B, then it would be equal to B plus A, and that is a commutative property, right? And therefore we have just changed the order and we have used the commutative property. Now you have to do is just group them together, this 837 and 363, right? Now which property is this one? This is the associative property of whole numbers. And you remember what was the associative property? It was like if A plus B and plus C, then it would be equal to A plus B plus C. Right? These just like here we group together A and B, but in this one we group together B and C. So similarly here we have grouped together 837 and 363. So this is the associative property of the whole number. And now if you would add it, what number you would get? Of course you are going to get 837 plus 363 would be 837, then 840, then 900, and this would be 1200. The sum of these two numbers would be 1200 and then plus 208. Now you could see that, hey, you got a zero digit, and I mean you manipulated that, okay, I can get a zero digit at the last if I add these two numbers, and somewhere what you got is 1200, which is now much more easier to add in 208 in comparison to adding these three numbers, right? You could see that clearly by some rearrangements and by some groupings, you got a simplified number. And then now if you would add this, then you would get, this is 1200 plus 208, it would be 14008. Now you saw that, now you see that how easily we got this number. And similarly we'll go here for this one. The second question says that it's 1962 and it's added by 453 and then it's added by 1538 and then by 647. Now similarly apply same trick or same method here. Now you could see that if I add 2 and 8, then 8 plus 2 is 10. And of course if I'll get a 0 as a digit in the number if I add 1962 and 1538. So it would simplify my number. So go on, make the arrangement. And one more thing, like here it is 3 and it is here. Of course 3 plus 7 would also give 10 and you'd get 0 as a digit at the last of the number. Okay, so the arrangements would be like this one. It would be 1962 plus 1538. Okay, and the next arrangement would be 453 and plus 647. And the reason we group together, that's because you just check it by adding the last digits whether you're getting 0 or not. So here if we add 2 and then 8, we'll get 0 in the last. Here also 7 plus 3, you would get the 0 in the last. So if you add this number, this would be 1962 plus 38, this would be 2000 and 3500. This number would be 3500, and you can check it by doing this, like 1962 and 1538, and if you add it, you would get 10, 1 carry, 6 7 10, 1 carry, 9 plus 10 5 and 1 carry, and this would be 3500. That is what we got here. And then add plus, what would you get if you add 453 and 647? So you would get 500 and 1100. Okay, you would get 1100 if you add 453 and 647. Now if you add these two, this would be 3500 plus 1100 would give you 4600. So you see here also you got 0 in as a digit, as the last digits in your number. And you could see that how simply we simplified our steps by some rearrangements, and we got the answer. So the trick is, like, you always check, you always go and check whether if I add two digits and if I'm getting as a 0, then group them together. If you're getting 0, then group them together, and you will find your answer in a much simpler and a faster way.